looks like we're on. So, it's been a while. My streaming and tutorialing schedule has been a mess since Christmas. So, I wanted to make a new one, and I'm sorry for how it came to be. I don't know how my schedule will look from now on, but I will try to make tutorials as often as I can. Well, without further ado, let's get into it. Today I want to make animated textures in Houdini and show you how to use them in Karma. And that will be the main point of the lesson. So first thing I'd like to do would be my texture. I have already made my project. My project files. So I just created this file path for my project, and I edited the aliases and variables, my job to be into that file, and then I have my hip files in the hips, and then I have my main file in the main file so that they are a little more organized. I'll close this for now. And let's make a geonode as usual. I would call it texture. And here I will make a simple line as I usually do. I'd like this line to go along Z direction. Let's maybe make this dark. We'll see if that's a good idea in a sec. I'll open this. Alright, we have a line. And this line will be the basis for our particle, because this will be a particle sim that will then make a geometry onto, and then rasterize it into cups, and then export it into animated textures. I will tell you why in a second, but let's do a poly extrude. So poly extrude, we have it here, goes, I could use this one, but yeah, it works a little weird, so I will use the other one, which is down here in extrude transform, and I want to make it like -1. And for whatever reason, let's make 10. Because in Houdini, Y axis is the top and down one, but in here I need to make it at Z to make it work, so that's weird, but we'll make use of that. So as usual, we'll try to make our setup as procedural as we can. So I will make this 10 points, let's say, and the length will be 1. I'll copy parameter for the length and paste relative reference here and duplicate it, multiply it by 0.5 and do a minus so that we are at the 0 location, which we might change later on, but we'll see. And then I'd like to make some attribute noise, and let's say that I'll also copy the points here and paste them in the divisions so that we'll have an even grid. Paste relative reference. Could I make a grid like this? Yeah, of course I could have, but I didn't. You can do that if you want. This gives us a little more control over everything if you want to, but yeah, this is arbitrary. Do whatever you want. We just need some kind of a emitter. So I'd like to make this density, and this will be a float value of black and white. I want a visualizer for it, edit it, make it ramped value of black grayscale. Pretty cool. And make it positive. Sure. A little smaller. A little like this maybe. Let's make it 50. Cool. I want this animated but pretty slow, so pulse duration I'll set to 8. See what happens. That our noise is like moving kinda everywhere. So I will also start here and animate it on the x-axis or maybe on z-axis. It will be $f times 0.1. Right, 0.1. Yeah, whatever. We can adjust it or not. Then let's see. Let's just make a pop net here. I'll apply it. Yeah, it kind of works, but it's not what we want. So for this, I really don't need a lot of particles, so I'll make it like maybe 0 here and 6 on the so every frame we are getting 6 particles, because impulse count is how many particles we are getting every frame. So if you would see this is like 6, 12, 18, 24, and so on. And constant rate is more like, I think, over a second, or maybe even like the whole. But let's not worry about that. This is our arbitrary stuff. We'll make an attribute emission, which is density that we've made. So wherever we have low density, we don't want particles, and where we have high density, we want particles. So I will also enable the ramp and crank the values like this, so the noise is like more, only these places will be getting particles. Let's see. Yeah, interesting enough. Okay, so yet later, I mean right now, I'd like to set this initial velocity to be, I don't want any variance to it. I want it to just go 1 into negative y direction. So my particles are falling. Well, pretty neat. Nothing special. And if you have watched my ink tutorial, then you will probably know my trick with replicating particles to make lines. Well, not really mine. None of these techniques or stuff are mine to be exact, you know. I just happened to learn that from someone else a long time ago, as you will from someone else yet again. But anyway, let's make pop replicate, and this other particles will be here, and I will merge them with these, and yeah, these ones are first of all not getting any attributes, so disable this and disable this, and the shape will be point, so they are just like right on top of it, and the number will be yet again 0 here and just 1 particle every frame. So now our particles are making streaks, but there is still a lot of them, like a lot. You can barely see what's happening. So let's make them live a little shorter, maybe 3 seconds. Let's see. Still a little long, maybe 0.75 second. What about that? Well, this might be good. So this will be our particle setup. Um, And also, just for the sake of clarity, I will make these ones also live a little shorter. We have only 10 seconds of animation here. So let's say this would be 10. Why not? All right. So now I would like to make a geometry, maybe a box. Box would be good. And it can be small, or one maybe. And then copy the points. These are our targets, and this is our gem. We are having these black boxes here for some reason. Why are they black? Because they are taking our visualizer. Don't do that. Yeah, they are small. They are pretty cool. So we have a wall of particles like this one. You can see them on the brighter screen down there. Let's close these maybe. Okay, it's getting pretty slow, so I'll pack them just for now. So it should be, yeah. Cool. So I like to set an attribute scale or just some random attributes on my particles so that they will scale the boxes somewhat randomly along their velocity axis or just the y-axis in this case. So let's do first of all attribute VOP, and here I will attach my particles. This will be attributes scale and whatever else I like. Cool. So what I will do, I'd like to divide life, which is our attribute. If you remember, we've set there how long each particle is supposed to live. Let's say life and age. So we have life of either 10 or 0.75, depending on whether you are a main particle or a replicated particle. And then the age is an attribute that just goes up until it dies, basically. So this one goes up until 10 and the other one goes up until 0.75. But if I divide age by life, so age by life, I don't know if I need to be this exact, and then do a visualize here, then I should be getting an attribute that is called visualizer or something. Yeah, vis visualize 1. So I'll just type here vis star and maybe it will work. Yeah. So now we are basically normalizing that value. So it goes from 0 to 1 when it goes from minimum age to the end of its life, basically. And I'd like to make an absolute of that value just for good measure. It won't hurt, but it might help. And then complement, not compare, complement it. So we are basically having a value from 0 to 1 and reverting it. So now it should be from 1 to 0. From 1 to 0 over the course of particles life. And then let's just make an bind export. And we have this, I'll call it scale. And scale is actually a vector attribute. We could use p-scale, which is a float, but that scales everything uniformly. I want to scale them in a particular direction. So scale, and let's do float to vector, why not? And for now, we will do parameter, and I will call it scale. Yeah, scale. No, I can't call it scale. I'll call it scale cubes. Scale cubes. And this will be a vector attribute. And let's do it again, vector to float. So, what's the big deal with this? So now I am splitting the vector into floats and combining it back together. So right now it should probably break because our attribute is at 0. But if I set it to 1 and actually use the node and visualize it, we are exactly where we were. But I can actually scale them. But whoa, what is happening? This is pretty cool actually, but not exactly what we want. So for some reason, some particles are getting a different normal direction. So let's quickly fix that. I will do I could do it in a separate triangle, but let's just do normal, and I'll make a vector, now constant of 0 or 1, 1 in the y-axis, and then stop it into n. This is not proper. Now they are all to the side. Because the copy to points always copies down the z-axis. So this is why this is not working. Let's try the z. And now we have a proper orientations for our particles. And this is looking pretty cool, but still way too dense. So let's actually use this and make maybe a fit. Let's see. I'll just take whatever happens to leave this parameter and multiply it by what we have here from our normalized age and plop it there. So okay, something changed, but not much. But if I would do it maybe like 2, now we have something a little different. Okay, so every particle has its size a little stretched down the y, because it's we are setting this to 2. This could be 3 or something else. and then multiplied by how long it's supposed to live. So if you are a young particle, then you are pretty long, and then as you are getting older, you are getting shorter. And that's pretty much what I want for this texture. This will be like this falling data thing, whatever. And let's actually try and rasterize this. So I'll just clean this a little up. So very simple setup. I actually made this simpler than in my initial setup. Way simpler and way more pleasant to look at. So, but it's usually this way. Here I'd like to make a cop network. And this will be our texture proper. Texture proper. Very cool. And let's say, yeah, you can be 1024 by now. Why not? I'll upres you later. This will be super procedural for now. Rasterize geometry. And if you're thinking like, why did you make this copy if you're going to rasterize it anyway? Then I can't actually just rasterize particles because Houdini doesn't know how the particle is supposed to look like. So I need to give it something. It can be sphere, it can be switch, it can be a box, but it needs actual geometry for the rasterization process, as far as I know. So I will actually make a switch with here and see the sphere and make it super small also. Yeah, so we can change it. But I like the box better for my effect. And I wanted to make a null here, and this will be out particle particles. Super good. And in this case, I'd like to sub import, and this will be external sub. Whoa. External sub called out particles. Rasterize it here. Okay, so something's clearly wrong here. I guess we need a rasterize setup for this, because we need to tell Houdini like how this data is supposed to get in here. Right now we just have one point. And in rasterize setup we are seeing our geometry, which is right, and we have y up, which is unusual, but this time it actually works. But here it still doesn't. So I would like to fit this to a reference box for sure. It doesn't work yet, but it should in a minute. Z up? No. Let's see what's wrong. Are the particles too small or something? Oh, that's huge. No way. It needs to work. So let's debug this quickly. I want the position. Y up is preferable, I think. Fit depth. And maybe I should have done that down the other axis. The line. Let's try rotating it. So transform. And let's transform it here. Well, we're getting something. Oh, is this the problem? No, this actually worked a little. No feeding. We'll get there eventually. Let's see. Bounding box. Okay, okay, we have it. So no rotation. And now we have something, but Z up? No, Y up. And this is clearly not the right orientation for it. Awkward. Oh, this is how you would like this reference stuff to work. Position, Y is up, but why can I only choose one of these? Okay, let's transform it again. Maybe here. How to... Oh, I translated it. Silly me. Yeah. All right. Now we have it, finally. But still, this is not... no feeding? Yeah, okay, feeding works. I want reference box because I just want like a piece of it. And I would also like to move this thing up so that they don't really spawn within my texture panel. I just want them to keep falling. But I also don't want is this that at the beginning there is nothing and then there is something. So I will actually do a time shift on my particles and move them plus 64 because I'm at at frame 64 there's something happening, like this is good enough, so I'll just start here and then make them fall and fall and fall all the time. So let's try and adjust one more thing. This, how about leaving a half a second? How about 0.1? How about 0.4? And here, how about 3 particles? Yeah, I want just some more of these holes between them. Dum 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 dum. Yeah, I'd say this is good. So I want this particle effect to be a little funky, so I'd like to bring some attributes into this. Let's see if they are here. Yeah, we have the ID. We have the ID of each of our particles, which is great. So here I'd like to bring another one, and let's say just another one, and I will say ID, and this will be ID. And this layer is, I will show you in a sec. So let's do a null. This layer is information is very special. It's different than color and data or something because Houdini can interpret this and basically the ID of our particle gets a random color in the representation, but this is very powerful because we can do stuff in cups particle related. And let's just try and scale this maybe 3. So they are a little longer pieces. Cool. All right. So I'd like to make a random mono, and I want to use the ID as seed. As you can see, this matches. This is ID, and now each of our particles gets a random value from 0 to 1 on the account of its ID. But I want to just move this part up so that our background is totally black, because I want the background to be totally black at all times. And now I will make two things. I like to make a multiply, and I'll multiply the initial values with the noised values, so that we basically get the same thing. Yeah, why am I doing this? I should just use the output of... Does this change? No, because we are using particle values, and that's good. But I don't like that they are actually moving this fast. I want them slower. So here I will make this velocity maybe 0.2. But this will also change everything else, so we need to take care of stuff. Maybe I could make this 0.1 and also particle, I would make simulation substeps of 8. Yeah, this slows our particle simulation down a little, but at this point, at this amount of particles, it shouldn't be that bad. Jeez, what's happening? Calm down. Ah, okay, this is because of the time shift. Yeah, you cool? Alright, let's see. So we have very, very much, very dense particle grid here. But I'd like to slow it down within the just after sim, so time retime, and I'll disable the time shift for now because it annoys me. Okay. So these particles, let's lock the time scale. They are still super fast, and there is much more of them than there was before. Because of the substeps that I used, maybe that's overkill. I might just do 3. U 240, and let's say by speed, I'd like to make this 0.1. Whoa. That seems super bad. Okay, let's disable this. Go back to this. And actually up here I can just scale time to 0.1. Let's see if that works. Because I don't really want to play with velocities. Okay. Bad. Everything is falling apart. Well, I guess I will leave them quick for now. Let's leave them quick for now. I could totally just enter this thing and do $F modulo 5 equals to 0. So now we will source every fifth frame. That's kind of cool. But it still doesn't resolve our problem with timescale. Well, the more work we put into this, the better it will look. So let's see, and then with the boxes, a lot. And if I pack it, does it still work in cups? Nope. So let's leave this unpacked. Wait, you can't see it? Why? Oh, it's too slow. Wow, this is super dense. Incredibly dense. I will go back to one substep and just scale the time. Okay, good enough. Let's see how fast or slow are they now. Boom, boom. Yeah, I had some problems with the timing of these. We can always come back here and make it slower later. Let's just carry on. So last time we were here, we achieved this randomness, and I'd like to make an edge detect on these here. So we'll have a value like this one and blur it by like 0.1 details. Let's say 1. But if we go higher later in the resolution, then this will work way better. If I do it 2K, then it looks very good. And maybe this blurring should be, whoa. Yeah, looks pretty good. I'll just add our randomness as background and our edge detect as foreground, and see how does that look. We need to adjust the time shift here by 124 or something. Let's actually do 180 or so. And do I need a particle cache for this? It's like 200 points. Okay, let's do a cache, why not? So drop down a file cache, call it FC particles. Okay, geo $OS, why not? Save it and forget it. But hopefully, in the end, it will look better than my original setup. So I'm kind of going off script a little bit, as I usually do. So this is what we are getting in the end right now, like at this point. And adding this and that, it's still too much points. I'd like to see how far we can go with delete here. But can you base it on ID? Rand from at ID plus random whatever seed is less than 0.5. How about that? And points. Okay, so this thing looks at our IDs and chooses which particles are supposed to die instantly and which ones are supposed to live on. And I kind of like this. This is good. Let's see what it does to our texture. Interesting. Let's drop down on the blur to maybe like 4. Yeah, okay. This is good enough. Let's not dally any longer. I will multiply it here with a value of a ramp, because I'd like this to disappear basically. This will be driving the, if you will want to see it, preview material, and blend this to opacity. So only this is visible, and it's actually, yeah. But what we'd like to do here is do a vertical ramp from 0 to 1 and multiply it by that, so they will actually start disappearing towards the bottom. And maybe make it like this and like this. Let's maybe select all of these and use a B-spline. Yeah, so I want them to start disappearing. Like that, maybe. Okay. And finally, and I mean finally, I'll do mono to RGB and source them here. And just choose some random values because I don't really want to be bothered. I am extending this as it is. This needs to be black. Yeah, this is funky enough. So our edge detect is getting much brighter than our initial points. Let's see how that would look without our randomness. Ah, okay, you can't source ID, right, obviously. Interesting. Why are they getting different values for the edges? Okay. Well, let's go with this. I will even skip the ID randomness. Or maybe blend it. Can I blend? Let's do this and like 0.4. Okay, so at 1 we have the full randomness, and at 0 we have full not randomness. Yeah, okay. And our nulls. So this will be no, 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 no. Out opacity, and not only opacity. And this would be out color. Let's make it universal. And here let's drop down output, wrap image outputs. This will be RNDR opacity and RNDR color. You know, I'll delete it because let's set this up and copy it later. So opacity here, jab slash caps textures opacity opaque $F, very nice, and yes, then copy it, add the color there, the color there, into opacity, into the cop path. This would be color, and this would be folder that is called color, and opaque is called now color. Yeah, but I will not be rendering this yet. Let's make the geometry now. So let's do another geometry container, and this will be bridge. And here I'll actually use. Let's do it, or maybe not. Hide other objects. I'd like to use a setup. So I like to create two things in here. One would be like this kind of random composition of points. That would be this like enigmatic data cigarette kind of thing. And the other one will be a bridge that then will animate and move. So I like to start with a sphere and points from volume. Why not? Points from volume. And I do want these to be uniform, not randomized, not zero jitter seed in there. Let's do 0.5 maybe. Oh, actually, let's make it 0.2 and just scale the sphere to be 10 by 10 by 10. All right, clip it. At Y and poly fill it. Go. Let's make it 0.5 or even more or less. And now I like to do a grid actually. Yet again. Okay, so this is huge. A huge grid. which is bad. I'd like this to be maybe 0.1 by 0.1. And then make a poly extrude. And this poly extrude will be very important because we need these side groups and front groups. And let's make it minus, or actually, let's make it up, move it up by 0.3. And let's see what happens. Copy the points. Copy the points. It should be like bad. Oh, it's actually not tragic. Let's change this to smooth shaded and add some normals. Okay. To make it work, I don't want this many points. So let's do something crazy like 2. But this should be bigger, maybe like 1 by 1. And the poly extrude be like 2. Okay, more like it. Let's do attribute randomize. 1 more points this time. And this could easily be scale. So now they get random values. But I'd like the values to be a little different. Let's say 0.1 by 0.1. No, never mind. Let's do 0.9 by 0.1 by 0.9. So they are mainly the same in their length, in their grid size, and mainly randomized in the Y size. But this should be maybe like something crazy. And maybe this should be like 1.6. I want them to actually touch each other, to be like kinda intersect even. So let's scale them up until that happens. Yeah, this is okay. And I want this structure to be, whoa, whatever is happening to my mouse there. So let's make this 2.8 or something. So they are all scaled, and yeah. I should probably, to make this a little more lightweight, do a group here and add another sphere, or even copy this one with a transform, add it here. This will be a group of points, and this sphere will be like 0.5 or so. And here I'd like to use bounding object, and let's make 0.75, blast them. Blast group 1. So our actual, I don't know if you can see, but this is now empty inside. So yeah, we are getting just less the geometry that is intersecting itself inside of it. Okay. So I'm not a big fan of this just one point here. So I'll just try scaling my sphere a little so that it looks more like this ziggurat thing that I'm trying to create. Let's say maybe like that. It will be 12 or so. Yeah, this is pretty good. And instead of randomizing it, I would actually like to do add noise so that we can add noise p-scale and make it float, add or set actually, and I want this to be positive and bigger than something like that. Pretty cool. We can always adjust these settings later. Okay, so now will be the part where these groups that we made will be very important. So I will do a split and see what we can do. Let's do split, and here I'd like to split it by extrude side. So we are just getting the walls, and there is a lot of stuff happening in there, but don't worry, it should work. I hope. And for each connected piece, and this connectivity should actually happen somewhere like here maybe. And let's select these. So we are having 408 prims, and for each of them I want to make UV unwrap. So the reason for this is that I don't want to just make a UV unwrap to everything, because I need the UV maps to be perfectly down the sides, so then we can animate the textures onto them. So with this way, we can just do the sides, and then actually, if you would see this UV map, we have all of the sides basically placed on here, and it's almost perfect. And I hope this randomization will not mess our UVs. But let's see. And in the second one should be of our top parts without any UVs at this point. Space one. Whoa. Good. So this is tops. So both these and the other ones have the class attribute, and we need to keep this class attribute very consistent because it will be important. So I will actually rename that class attribute because for whatever reason I should do it later on, but okay, let's merge it for now. I will be renaming that attribute in a second because USD for some reason cannot read class, but it can read basically anything else. And let's do UV texture, maybe. I don't think I'll be texturing these top parts, but yeah, let's leave it like that. I will be getting entirely different treatment here. So I'm merging this and then doing a rest position. Wait, maybe not. Okay. So this is more or less what we need. Let's see if we can get it into Solaris. So I will say this is out structure. I was supposed to make a bridge. I know, I remember. Jeez. Yeah, network view. The structure. The bridge will be the next one to do. But first, let's see if it works. So I am adding my Karma renders stuff. This is basically just a pre-made, simple, just everything that you need for a basic render. So if you make a lob, then this is Karma renderer, and I have a stage. This should not be composed this way. It should be more top down, like this. This to that, and this to that, and then that to that, to this, so that you have a stream of geometry, lights, cameras, and you know what, actually let's leave it. So I will leave it like this, and this geometry will be our structure. So this is a SOP import node, and let's use it. Yeah. And I will just call it data prison or something. And this is structure. Load as reference, subpath, and want this structure. So it should be in here, right? Yeah. Okay, so it will look like our dome light is acting up. So the structure is here. I will launch a quick texture cache in the background. Let's do this, both of them. And render frame range and render them to disk. Very good reminder indeed. So I will save this and recache and render this to background, to disk in background. So this will happen in our render scheduler. Right? So our animated textures should be done in a minute. And the reason I am caching this out is because you technically can just make material references to cop nodes. I can just reference this. So this is also a preset material that I did. Let's close this diffuse. We will be making them from scratch anyway. So these are textures. I'm just deleting everything, and so here I want image, MTLX image, no, EMG, MTLX image, just normal one. And here let's load color, and let's actually load this for now. Let's call it OP colon because this is the proper context. And if I use this as, let's say, opacity, and make sure everything is kinda set, let's call this emissive animated. It's not yet emissive, but we'll get there. And here I actually wanted to split these, but for now let's just do import data and subset groups, and I'll just play star. So it imports all of our groups, which is extrude front and extrude side, which is exactly what I like. And I'll clear my materials and use this animated one and to the sides. So as you can see, this is actually working, and we are having our data structure in here, and it's actually animated in the viewport, which is pretty cool, even though this is just cups. But if you would like to see this, let's make this dark and disable the grid. But if I would make this, for example, a flipbook and scoped, yeah, whatever, then last time I checked, huh, well, now you're working, right? Okay. Well, last time I did this didn't work. The textures didn't update from cops, basically. This is why I cached them. So yeah, be wary of that, so that it can sometimes happen. This should totally not work, but yeah. And there is also this allow shader parameter animation in here, which we technically also should. Let's maybe see if this works in Karma render. What a interesting turn of events. I'll just copy this and say this is diffuse. But this one will not be getting any images. This will be just fairly dark kind of thing. Some mostly rough. And I will add it to the top parts so that it's not just this default white. Yeah, so that we have something more interesting or whatever. So we have this data structure animated and working, which is pretty good. Oh, wait, I know, because it works in the preview, but let's see if it works in the actual render view. So I'll do karma. And it's okay. It works for now. I need to adjust the settings. So this would be XPU and make super low. And I like to make flipbook with new settings. Let's just do from 1 to 10. Go. This will regretfully take a while, but I'd like to. Oh wait, it's actually not happening, or is it? Yeah, it is. So what I think is happening is that Karma takes and compiles renders for the render process, and it just does it once. So basically our textures should not be animated anymore, I think. What is going on? Let's see. But I think we can see that whatever the problem is in here, that with the size of it, our textures are not animated anymore. And this is why I used the caches and just rendered these texture sequences as... I actually did this wrong, so I'll delete my my cache and do it again. Other background render, and hopefully not crash this time. Okay, really easy, really slow. So one more thing that I want from this is to, because this is not animated, we don't need that much stuff, but I want a rename here. But let's see let's just let this finish, this percent, this render of our texture. And in the meantime, I can actually hook up the diffuse and the emissive with an actual render from my job, caps, textures, opacity, this one. So this is actual rendered out cops sequence, which is super good. And the other one is finished as well. It says an error here, or a warning actually, that you can have nodes depending on time, but you actually can for some reason. Don't ask me why that works like that, but it does for now. So animated textures are here, structure is here, and let's see this node, and let's see this scene graph details. So I want this structure here. Wait, how can I bring it here? Make it 2 or something. I can't see any values. Let's see, scene graph tree or geometry spreadsheet. Okay, structure. So here are the actual USD values that we are getting, and on this mesh 0, we have some stuff. We have normals, orientation. This is the color of the actual points, if you have some. I don't. This is alpha. So these primvars are something like USD stuff, and supposedly our I want the class that I made for each one of these to be basically imported into Solaris as a Primvar. So I will rename class. And basically what I need to do is, this is primitive attribute as far as I'm concerned. Yes, it is. I'll just do one class to myclass. And now let's see this structure, and we see this Primvar myclass, and it's there. It just doesn't, just has to be named something else. So these primvars are like attributes, but within USD, and they are primvars, I suppose, for primitive variables or something like that. But what's important that I can use the Primvar in my shader. So I'd like to adjust the color of every single one of my boxes here by some random value based on the Primvars. And this is what I will do. So in a sec, let's do this node called USD Primvar reader. So this is a node that can read these primvars, and this will be get class, and I will get my class, which is class but renamed. And now I want random color, let's say. And also let's do emission, which should be like emission 10. And here I will enter Solaris just to refresh my viewport to see what's happening. And I'm doing, this is a very awesome node, very awesome way of randomizing because you have controls over the hue of the color and the saturation of it, and this random color into the emission color. And then this. And, oh, and we also need this as emission map, right? Or wrong? Let's try base color. And let's try the rendered view, because this might be too much for our little Vulkan viewport. Oh, okay, we have something. They got violet now. And apparently our class should be a int. You could think that, yeah, this doesn't matter, but it actually does matter for the USD, that it is an int, because it's not a float, it's just one value for every single one of these. So we have it, and now our data is structured, has a random colors to it. This is the random colors on the animated textures there. And yeah, very nice. And we could totally do some falling stuff out of all of these and make it a particle system and don't bother with it. But the approach with the animated textures is actually pretty flexible. I got inspired by game design principles that they do a lot of stuff with textures. So that now if you want to change something, maybe I can just do a UV transform. And this is a custom parameter that I made in this node, that don't worry about it. I'll just delete these channels. You just have this scale, and if we scale the transfer, the UVs of these times 2 and do it, so times 2, times 3, times whatever, we can manipulate the output of our render, because these are the textures. Now we have more of these falling data pieces. And thanks to the randomization in the material and the Primvar reader, we can actually use, let's multiply, emission. Okay. And use this as emission color. And this emission should be maybe times 10. And base color, maybe just let's leave it. So what I actually wanted is that our texture is just these falling pieces. It doesn't have any tangibility to it, and it actually bothered me quite a little. Let's just change this color because it's too crazy. So I'll just adjust these values so that we have a hue range. So now we are just using some from blue to maybe like this. So now they are all bluish and violetish, and we can also adjust the saturation range and the brightness range. So that's a very, very nice way of using randomization of color. I like this. This is looking good. So last thing that I wanted to do is like make a ramp that would make these tops of these values just ever so slightly more tangible. So I will import a texture coordinate node. So these are our U and V of our UVs. And I will separate vector 2 in here and drop it here. So we are getting the vector, so this is the U and this is the V. And I want to make constant, ramp constant actually. So this will be a float ramp, or it could actually be color ramp, whatever. So let's drop this into the base color. And I'll zoom in so that we can see better what's happening. And I'll actually drop this to an add to the emission, otherwise it might not work, I think. We're not using this. Let's just do emission and just do opacity. And yeah, it's broke everything. Let's try and fix it. So this ramp is right now from 1 on top to 0 on the bottom, but our pieces are kind of long, so I'll just drop this low point. Huh, I think I actually took the wrong coordinate. Or did I? Well, let's try with use. We might need to adjust the setup for... We could easily do this in cops. This is very easy fix. But... yeah, it would appear... Wait, our... Huh. Let's see, the sum of our animated texture are animated sideways. And can I see this in the Houdini? VK? Vulkan preview? No? Why? I guess you don't really like any emission stuff. You would just want the base color or opacity. Okay, I will indulge you just for the sake of it. Huh. Well, it appears solid. I don't see any sideways going values anywhere. Let's drop this into opacity. Let's make it a vector ramp. Use the V. Float maybe. Why? Why you do this to me right now? Hmm. Wait, I'm taking texture coordinates, which is U and V. And then let's try and do color ramp actually. Vector color of Inferno and output it. Hmm? Do you have base color? You do. Ah, emission is there, obviously. Silly me. Alright, yes. So now float value, yeah, keep watch on that. And if we drop this into opacity, then they will just disappear slowly. What is going on? It would appear some of the values in the textures are wrong, but I don't think that's the case. You know what? This tutorial has been going way too long enough, so I'll just use randomized colors on the emission, use let's add both of these and see what happens. Opacity. Maybe I should drop these down. Yeah, I don't know. I actually like this. It's not what I wanted. Something's wrong, but well, let's cut some corners here, and this will be also emission ramp. Multiply it so that it's stronger, maybe like 10. And it looks super bad actually with this kind of colors. So maybe just 2. And this is our data fortress. I think this has been going on long enough, so I'll wrap this up. And yeah, basically I'll just so important thing that we learned is this, that you cannot bring just class attribute into USD. At least I don't know if this is because this is a reserved name that Houdini uses and you can't use class. You just need to rename it to myclass, and that you can actually import data from your subs into Solaris using import with these Primvars. Just check that your actual data is there, and that check that it is the correct type. It can't be float if it's an int and whatever. And you can then use the data in materials So that's also pretty cool. And then actually animate stuff using that. And how to make a simple animated textures with your simulation from pops, and like this one, and bring it into Copernicus and do some more stuff on it. And this texture would also, if I wanted to make, for example, I will drop down Tommy here, Tommy, and let's say no, Tommy, here. I can do sub import, use external sub, and this can be Tommy. If I would do this as a preview geo, you can see how our texture is looking on Tommy, and it's actually looking pretty nice. It's flowing down the UV values, and we can always scale this up. And because this is animated textures, it's pretty lightweight. Instead of, I don't know, copying hundreds and hundreds of elements and stuff, and getting the deformation on the mesh would also be a pain. So yeah, we could do 100 different things with that in cops and in subs, but this will be like the part 2, where I will make the bridge and I will animate it using mops, and we will then make this data structure and finalize our render. So thank you guys for watching. I hope you enjoyed, and see you in the next one.